What's up, everyone? My name is Dustin, and I'm back again on the computer, screen capture. Um, so today I'm going to show you guys how you can make parts that you want to be 3D printed. So you need a part made for whatever, and I'm going to show you the basic way on how to make them. That way you can 3D print them if you have a 3D printer. So this is Autodesk Inventor, and this is what I'm going to be showing you how to do this in. You can use other 3D software like Google SketchUp or Blender, or this, that, and the other, but this is what I've been using for 6 years or so. It's what I know best. So I'm going to try to show you guys how to make a certain part that I'm using on my 3D printer. I'll probably put a picture up right now. That thing. Basically, it just holds up the wiring looms that I have. I made it right after I bought or built the 3D printer, and it works really well for what it's designed to do. So anyway, it was really easy to print, and I will show you how to do that now. So anyway, first off, you need Autodesk Inventor. If you are a student at a university or college, you can get this for free for a 3-year license. It's completely free. You just got to put in all your student information, blah blah blah, whatever they require. I did it back in the day when you could just put in like a different address. You can put in a European address and you would get it for free anyway, even though I was in high school. I didn't have a college email, so I couldn't get it for free, but you put in a European address that worked. So I don't know if that would still work nowadays, but that's what my account is under, and that's what works, even though I'm a student. But anyway, so you'll need to start it up. This is the start one for Autodesk Inventor 2015, if I'm not mistaken. I used to use 2010 for the longest time, but the license expired after 3 years, so I had to get the new one. So this is the new one. So once you're on the start screen like this, you can hit Part, and it'll open up a new Part window. So this is where you'll go and design whatever you want to design. So I have to say, although I've been using Inventor for a long time, I'm not a professional at it. I'm not, super well in it. So for those of you who are watching this who do use it a whole lot and are professionals at it, you're probably going to see me doing things and go, no, that's not what you're supposed to do. You can do it 10 times quicker with this. I understand. And if you have any tips like that, feel free to comment them in the comments, obviously. So I and others can see, and that would help out greatly. But for the most part, I know pretty much how to do what I'm trying to do. So anyway, you got a blank screen right here. If you have like 2011 or back, then I think the 2D sketch planes will already be displayed. I can't remember. So if not, you can just hit the Start 2D Sketch right there, and you're going to get a couple planes you can play with, X, Y, and Z plane. Or the XY, blah, blah, blah. Anyway, I usually click this one. Doesn't really matter at this point, but so now you can design things in 3 dimensions, or 2 dimensions originally, or even 1 dimension if you want. So what I'm trying to make is this part. I'm going to take my handy calipers and measure it all. If my voice sounds deeper than it usually does, that's because I just woke up and my voice is kind of deep when I wake up, so I didn't prepare for this. I'm just like, nobody's home, I can record. So anyway, digital calipers or regular calipers, whichever floats your boat. I highly recommend getting a pair of digital calipers, or regular calipers for that matter, because using a ruler really sucks when you're doing very accurate things that you want to be 3D printed. Digital calipers especially are very accurate, and you can pick imperial units, metric units, even fractional units if you need to. The one I have is a cheap one from Harbor Freight. I got it for $9 on sale. So if you want, you can go to Lowe's or Home Depot or something and get some for like $30 or so. That's fine. You can pay $100 for one if we want. That's fine. But the ones that I use are $9 ones, and they're absolutely wonderful. So anyway, get your pair of calipers and measure away. So I know that the width of this part that I'm making is 0.7 inches, but I want metric because metric. So this is, now I remember, 19 millimeters wide by approximately 60 if I'm not mistaken. So So once you know what size you need, you can just go and click the rectangle thing and start it right on the middle dot and just make a square, because you can always size it later. You can just hit this dimension button right up here, click any side, and boom, you can dimension it. It defaults to inches. You can change it in the settings, but you can just enter it in as millimeters too. So I know that lengthwise I want about 60 millimeter. Make sure you put mm for millimeter. You can put centimeter or meter, I think, too. So that shows you it's 2.362 inches. And you also want here 19 millimeter, not MK. So that's the rough general shape of what we're trying to go for. So now what I'm going to do is actually extrude this out to make it three-dimensional. So you hit Finish Sketch, and you have an isometric view of your two-dimensional shape. You can just hit Extrude right here, and it extrudes it out. I have my part extruded out to 13 millimeter, so I'm just going to put that to 13 millimeter. And now we have a three-dimensional block, pretty much. So that was the additive process. Now you just have to do the subtractive process. I must remind you, though, that when you're designing parts for 3D printing, if you've been doing 3D printing for a long time, you know the problems you can have when things are designed incorrectly. If you have a lot of overhang, if you have things that aren't really going to be supported, you're going to have problems while 3D printing. So you want to design things knowing that. You want to design parts knowing how you want to orient them to be printed. That way they're going to have the best chance of succeeding. So for this one, it's actually on its side right now, and when I print it, it's actually going to be this side right here down. So you'll see it when I finish it. So anyway, I'm going to change the view over here to the front. So this is what they say front view. It's actually the top view. You can actually, if you would have picked the right plane in the beginning, it would have made more sense, but I don't really care. So anyway, this is the new top, which I'm going to be adding the small holes that are going to be going onto the wiring loom. So I'm going to start another 2D sketch and click the surface, and it's going to start a sketch there. So now I'm going to create a couple circles. First off, I'm going to measure about how big the radius of the circle is, and if I remember correctly, it was like 14.6 millimeter is the diameter of the circle that I'm using. So 14.5, 14.6, just for a little bit of extra. So I'm just going to put two random circles here. The accuracy of them don't really matter at this point, because you can always adjust this stuff. So I am going to dimension them to the correct size, which should be 14.6 millimeter. And then this one, 14.6 millimeter. So first off, we want to place this circle into the middle of this direction. Whatever. So first off, you're going to click the dimension button. You can click the middle, and you can click an edge. You can click an edge. There you go. You can click an edge. So now you have that dimension that you can make. You leave this right here. It doesn't really matter what it is at this very moment. Now click the same thing and do the other side and drag that out. That is going to warn you that that is a driven dimension, which means it cannot be modified because of this dimension, which makes sense. Because this dimension is already here, you already set the main dimension of the main part. This one is only going to be whatever it is. You can't change it, because then that would change one of the other ones. So basically all you have to do is get these numbers pretty close to each other. I could do the math, but I'm not really going to. So that's close. 0.375, how about 0.374? That'll work. So that's pretty much dead center. I know that there's other constraints and stuff you could do to make them, to do it quicker, but I don't really care. I've never done it that way, and this way usually is quicker, because when I'm in my prime and not making a video, I can usually math very quickly. So I'm going to put this one over here first, 0.374. So now they're both going to be in the same spot, and what I'm going to do is, because of the way I designed the original part, I'm going to actually measure the distance between the edge of this circle here and the edge of the circle here. And that is approximately 29 millimeters. So I'm going to measure from here to here. It's going to give me that 29 millimeter. And see, that's going to pull it way over yonder, which is fine. We can move these later. So anyway, I'm going to try to position this here. No, that's not what I want. Let's try this edge to this edge to that. Bastards. I wonder if that scared people. Probably not. The hardest part of doing dimensions is getting them to work exactly where you want them. That's the only problem I ever have. I'll just do this one first. So this one I have that measurement in this dimension. Now I have that one. And it's also going to be driven because of the way I'm designing it. So now we just want to make those two match. So let's see, I don't know, 0.4 or 7, whatever. It's a little bit less. 0.31. 0.32. Okay, so 0.323. There we go. Again, there's probably quicker ways to do it. I don't do that. Don't learn from me, kids. Learn from someone else who's better at this. Anyway, so now we have the circles, and they're pretty much in the right spot that they need to be. What I'm going to do now is I'm going to extrude these two holes, but extrude them backwards. So this one right here is the cut. And you can choose the distance if you don't need to go all the way through. I'm just going to leave it where it is because it's going to cut all the way through. So now we have a part with two holes, which is cool. So now what I'm going to do is cut out the little slot over here. Instead of leaving the circles out on the edge, I'm just going to cut a slot from where it is. So I'm going to start another sketch. You could have also done these cuts in with the circles, and you could have made it all one part. But so what I want to do is project geometry. So that gives me this whole shape as things I can choose, which helps out in the end when I need to extrude things out. So for this part, I'm just going to do a basic line over. And you want it to be able to curve over. I keep wanting to point at the screen, but I know you can't see what I'm doing. You want it to be able to curve over a little bit so it'll hook onto the wiring loom, but you don't want it to curve over too much or else you're going to have trouble getting the wiring loom in here. Of course, if you were using something you could slide in through the hole, you wouldn't even have to do what I'm doing, but that's beside the point. So, what you're going to do is click dimension, in this dimension from here to here. You have that dimension from here to here. You have that dimension. And just make them the same thing. Just, kind of see what you can get. I'm looking at the part that I already made. I went through some trial and error getting it correct. So I'm just going to kind of base it on that, which I think was 0.13 or so. Yeah, more like about that. So I'm just going to make the same one here. 0.13. And I am going between inches and millimeters here. Most of the stuff I do is when I'm actually measuring something on a certain part, if I'm trying to duplicate a part, is going to be in metric, just because the metric system is a little easier to use when you're 3D printing because everything is already in metric. So when I'm just freehanding things, like what I'm doing here, I'll use whatever the default one is, which happens to be inches. Again, you can change that somewhere in the settings, but I haven't because this is on my new computer. So anyway, this is going to be here. I'm just going to make a small one to connect this because sometimes that doesn't work. And I'm also going to make an arc connecting these. It's going to default right onto that. That way I have this shape cut out. Sometimes it doesn't work if you don't make all the sides. So I'm going to just cover myself at that point right there. And then I'm going to make the same thing over here. And I also hope that I am saying the correct measurements when I say things like this, like 0.13 and not 0.31, because I tend to have a little bit of dyslexia in that sort of thing. So if all of a sudden I type in something and it has nothing to do with what I just said, ignore that. That's me being stupid. So anyway, now that I have both sides done, I can finish the sketch, and I can do the same extrusion thing. Again, you could have designed this part as part of the circles, and you could have just extruded it all at once. Make sure you set to cut, and now that part's cut out. Now the last thing to do is just kind of smooth out the edges a little bit. So what I'm going to do is go to the fillet or fillet if you're French, or any other thing, and I'm going to, that's not what I wanted, click the edges that I want to round over. So it'll be these edges, and we're going to pick a pretty big round over. It's actually going to interfere with everything, so you can see that's a little bit more. I'm going to do something big. That looks pretty good. Yeah, that looks okay. So you can see there, I have rounded over the edges to make it look a little bit nicer. I'm going to also do these very far edges, not going to be as much though. So once I pick all of them, see how it's rounded over them pretty severely now. I'm going to change that back to 0.125 or so. Yeah, that'll work. It looks kind of wonky, but that's fine. And then you could unsharpen this edge, which I think I will. I'll just turn it way down. No, don't do that. Then do this one, and then turn this to something way small. No, that's too... That'll work. So now you have pretty much a basic part done. Look at that. If you followed along, you now have a part that would probably work just fine on your system. I'm doing this, designing it to a part that I've already made. If you want to make stuff completely from scratch, that's absolutely fine as well. I do that pretty much when I designed this original part. I did it from scratch. If the best thing I can say if you're going to do that is to draw it out on paper first with all the measurements. That way you have a basis to go off of. If you're designing or copying an already existing part, make sure you have a pair of calipers so you can measure everything very accurately. Otherwise, all you pretty much need is a sketch or something like that that you can copy off of very easily. Most of the time I don't do any sort of sketches or anything. I just go at freehand because I'm pretty good at that. I've been doing it for a long time, so I'm pretty good at it. But when I get to really, really intricate things, I will design them out on graph paper or ISO paper, and then put in all the measurements as well, even if it's not exactly to scale. That way I can go into Inventor and already have all the measurements I need and just pretty much make the 3D version. So now you have a part. You can also go and round over these other edges, but because I'm 3D printing this, I want the edge, the bottom edge at least, to be completely flat. I don't really care that much about it being a little sharp. I'm not going to be touching it or anything. But anyway, this is the part. You can round over these edges as well, but again, I'm not really going to worry about it. So now you need this file. You need to make this thing an STL file. So what you're going to want to do is go over to the Inventor logo up here. You're going to want to go, there are two ways you can do it. I think you can save as an STL, but I like doing it this way. You hit print, or don't click print, you hold over print and hit send to 3D print service. And then you're going to export it as an STL, all visible, make sure the scale is exactly at 1, and just hit OK. And it's going to tell you to save it, so you're going to want to go to whatever you want to save it as. So I'm just going to say, I don't know, example part, because I'm not going to print this. I already have one. And it's going to open up your internet browser to go, hey, look it, you can totally send this to someone who can print it for you. Send it to Shapeways, send it to the Z Corp, you know, whatever. You can just exit that out, doesn't matter. When you said send to 3D print service, they literally meant, you know, do you want to send it to a 3D printing service? So you can just exit out of that. It saved the file, so now when you go into your documents, it'll be right here. So I have example part.stl right there. Now you can go and simply take it into any of your slicer programs and there you go. You put that STL directly in there, make sure that everything is 1-to-1, slice it up, and you can put it in your printer. So that's the quickest and easiest way to do things. I know I didn't go through pretty much any of the main features of Inventor, but this is just the basics of it. If you want me to do more of these videos, please tell me, because then I will. If not, I'll probably do them anyway because I'm bored. So yeah, that's pretty much it. I will probably be doing more in the future just because I enjoy doing it. And if there's anything specific you'd like to see on how to make in here, or even if there's some sort of design you'd like to know how to do, please tell me. I'll see if I can do something like that. For those of you who are wondering, which may be a couple of you, Autodesk Inventor is very good at part making. So if you need to make hard edge parts for, whatever your 3D printer or even your vehicle or something like that, that's what this is really good for. If you want to do 3D design of characters or soft edge, more rounded things, Autodesk Inventor, you can get away with it, but it's not really designed to do that. What I recommend is 3ds Max, which is also an Autodesk program. You can also get it for free. If you're a student, you can get any Autodesk program for free for 3 years because you're a student. So 3ds Max is also a 3D design software, which is really good with 3D printing if you're into that kind of thing. But I don't really know how to use it at all, so that's why I don't use it. So anyway, I hope that this has made some sort of sense to you. If not, I'm sorry. I've tried. I've failed you. That's okay. If it has, now you know how to use it. So anyway, I will see y'all later.